Okay, now that we've understood a little bit about how ionic and covalent bonding works, we're going to dive into what is known as the covalent bonding using Lewis dot structures. So we will introduce it, and then we will develop some rules for you to be able to draw these successfully yourself. Hydrogen has the Lewis dot structure that looks like that. That line in between represents two electrons in a bond. And what is happening with those electrons is those electrons are being shared. This is known as a covalent bond. Lewis dot structures are most useful for atoms that are covalently bonded together. And the driving force behind covalent bonding is what is known as the octet rule. Octet represents 8, and in our case it is 8 electrons. Elements combine to have their 8 valence electrons, and that is a stable position for them to be. What is stable for hydrogen, however, is only 2 electrons. And the way the electrons are distributed about an atom lead to what are known as shared or bonded pairs and unshared electron pairs. And those are pairs of electrons that do not participate in the chemical bond. And I'll show you an example of that as we draw the Lewis dot structure for oxygen. Oxygen has what is known as a double bond. It is a bond that involves 4 electrons. Those are called shared pairs of electrons. So these are known as the shared pairs. That is a double bond. And if you look at the entire molecule, you will notice that each oxygen has 8 electrons around it. So 2, 4, 6, 8. And this oxygen is also sharing those electrons, so it sees itself as having 2, 4, 6, 8 electrons as well. So these electrons are in their octet. That makes O2 a very stable molecule. A triple covalent bond is a bond that involves 6 electrons in shared pairs. So there are 3 shared pairs, but that equals 6 electrons. And in oxygen, there's 4 electrons, which are 2 shared pairs. And the bonding for nitrogen involves a triple bond, and it looks like that. So let's discover now what the rules are for determining how to draw a correct Lewis dot structure. Add up the total valence electrons for each atom in the molecule. Then what you do is you write the symbol for the atom in the molecule. In simple molecules, one atom will be called the central atom, and it will be surrounded by the other atoms. The central atom is often the first atom in a formula. So in the case of CCl4, carbon begins in the middle. And by central, I am saying that all other atoms in that molecule connect to it. There is only one atom that will not be the central atom, and that is hydrogen, because hydrogen can only form one covalent bond. So in water, oxygen is the central atom, and hydrogen will be on the outside. So there are what I call lone pairs of electrons that would be in a finished Lewis dot structure for those, and I just put those in. So after you have identified the central atom, what you do is you draw a line, and that line is called the bond, and it is equal to 2 electrons. So you draw a line between each pair of atoms that are covalently bonded together. For each dash you drew, what you need to do is you need to subtract 2 electrons for each dash from the total number of valence electrons. Then what you do is you draw the remaining electrons as dots, and we will always do them in pairs. So 2 dots will be together north, south, east, and west around the element symbol. Arrange the dots so that most atoms have 8 valence electrons, and of course hydrogen would only have 2. Now, if there are not enough electrons to give the atoms a full octet, 8 electrons, you shift unbonded electrons, the dots, as needed, or you change single bonds to double or even triple bonds, and you do that by subtracting a lone pair of electrons. You erase unbonded electrons for each line that you draw, and that would be 2 electrons. So what we're looking is for each atom to have a noble gas structure, which is called a full octet, or 8 electrons. Now occasionally we'll encounter an ion, and an ion will have what I will call extra electrons if that ion has a negative charge, like NO3 has a -1 charge. In that case, we would add 1 extra electron. If it has a -2 charge, like SO4 does, you would add 2 extra electrons. Or if it has a positive charge, there would be fewer electrons. And an instance of that we will do below is NH4 that has a +1 charge. We would have 1 fewer electron. So this will change your total number of electrons or valence electrons that are available for the compound's dot structure. So let's walk through a couple of examples. So I2 is a covalent molecule, and each iodine has 7 valence electrons, and so that gives me a total of 14 electrons. I draw the symbol for each atom, and there are 2, so I draw 2 individual iodines. I put a line in between it. That means that I have used up 2 of the 14 electrons. Now I want to give each atom 8 total. So the bond counts as 2, so I've just added 2 more. So that's 2, 4, 6, 8, 10, 12. That's it. That's all the electrons I can add. Now I want to see, do each of my atoms have 8 electrons around it? So looking at that iodine, that's 2, 4, 6, 8. And then looking at this iodine, the bond is 2, 4, 6, 8. That means I have a total of 8 electrons around each atom. My last check is going to be to determine that I have actually all the valence electrons that I should. So there's 2 up here, there's 2 there, 2 there, 2 there, 2 there, 2 there. So 2, 4, 6, 8, 10, 12, 14. My final picture should have 14 electrons that are shown. Let me erase my work and just leave the actual drawing of the molecule for you to check your work. Let's do HF. H has 1 electron. Fluorine has 7. 1 plus 7 is equal to 8. This one I think is going to be very simple. Hydrogen has a bond on it. It wants 2 electrons, so it has all that it's need. We now have 6 electrons left to place, and I'm going to put them on the fluorine. And you see that the fluorine is going to have 2, 4, 6, 8 total electrons, and that is going to be a valid Lewis dot structure for HF. SO2, sulfur has 6 valence electrons. Each oxygen also has 6, so that's going to be 6 plus 6 plus 6. That's equal to 18 total valence electrons. So I'm going to slow down just a little bit because this is going to involve a little bit of work to get this one correct. I have sulfur as the central atom. Each oxygen I put on either side and I draw a bond to it. That bond on each side represents 2 electrons. So I have already used up 4 of my 18 electrons. I now have 14 left to go. I'm going to start on the outside and give the outside atoms their 8. So it has a bond on it. And so 1, 2, 3, 4, 5, 6 gives that oxygen 8. 7, 8, 9, 10, 11, 12, and I have 2 more left. I will now put them on the central atom. So as I go about my checks, I recognize that this oxygen has 8, that oxygen has 8, but the sulfur in the middle currently has only 6 electrons. 2 of those electrons are what I call a lone pair, and then the 2 bonds. So in order to give the sulfur all the 8 electrons it needs, I am going to erase those 2 dots. So I'm going to take a lone pair and I'm going to share it. So by erasing it, what I've done is I have shared a pair between the sulfur and the oxygen in addition to the single bond that was there. So now I have a double bond. Let's count electrons. This oxygen, 8. This oxygen, 4 electrons in bonds and 4 electrons in lone pairs. And then the sulfur in the middle, 2, 4, 6, 8. Everyone has 8 electrons surrounding it. And now let's count up the total. On the oxygen on the left, 2, 4, 6, 8, 10, 12, 14, 16, 18. That is the correct total. This is a valid Lewis dot structure. SO3, let's look at it. Sulfur has 6 valence electrons and there are 3 oxygens. Each of them has 6. This gives us 6 plus 18 is equal to 24 total electrons. So we start out this time with 3 oxygens, and I have placed 3 bonds. So 24 minus 6, I have 18 electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Uh-oh, I've run out of electrons. And all the oxygens have 8 around them. They have 3 lone pairs and 1 bonded pair to give 8, and they're all identical. However, the sulfur only currently has 6. So I need to take away a lone pair from an oxygen and share it to the sulfur. This is why we fill the outside atoms first, because we can always share to the middle. Now I can choose any one of my 3 oxygens to share that pair from, so I just happen to choose the bottom one, and I draw a double bond to share that pair. I'm going to count and make sure that I've got 8 on everybody. So this oxygen has 8, that oxygen has 8, this oxygen has 8, and the sulfur 2, 4, 6, 8. It has 8 as well, all in bonds. So my final Lewis dot structure is going to look like this. Carbon dioxide carbon has 4 valence and oxygen has 6, but there are 2 of them. So this gives me a total of 16 electrons. So we start out with carbon in the middle, a single bond to each. I now have 12 electrons left to place. So 2, 4, 6, 8, 10, 12. Always start with the outside. Carbon obviously does not have enough electrons on it. So I'm going to erase a pair. I'm going to share a lone pair. And I'm going to share another lone pair. That is the valid Lewis dot structure for carbon dioxide. CO3-2 presents us with something new. Carbon has 4. There are 3 oxygens that have 6 each, and now I have a -2 charge. That means there are 2 additional electrons. Electrons have a negative charge, so when it says -2, that means I add 2 electrons to the total number of valence electrons that I have available. So that's 4 plus 18 plus 2. I have 24 electrons to work with. So I'm going to now go and draw my beginning picture. I have 3 oxygens, each with a bond to it, so that's going to mean 6 electrons less, 18 electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18. All the oxygens have 8, but the carbon in the middle only has 2. So I'm going to erase a lone pair and share it. One of the oxygens has a double bond on it. The other 2 have single bonds. Whenever I have an ion, I will put brackets around it and the charge, in this case -2, outside the brackets. So at this point, I'm going to stop the video. And what I want you to do is to stop. And on the following page, you have a number of examples that you are to do. So go ahead and do that. You stop the video right now, work on those, and then pause this video and restart it once you've finished. Pause your video. I am now going to restart the video and show you the answers for the work on the next page.